All right, folks. Good evening. So today we're looking at the attributes of square root and cube root functions. Today, this first part is a lot about transformations, and then the second part will be about domain range and intercepts. I'm gonna go through this real fast. You've seen this. Hopefully, you've seen this before. You'll be familiar with it. This is the kind of the transformation notation for functions. Just so you know that f represents the function. Okay, itself. You have A's, which are vertical stretch compressions. Okay. It's also the vertical reflection across the x-axis. So if A was negative, okay. So if A was negative, then it would reflect across the x-axis. You have B, which is a horizontal stretch compression by a factor of 1 over B. Sorry, you can't see that. And this is the one that does the reflection across the y-axis. Okay. And I'll show you more about these as I get into it. That's going to kind of give you a rundown of this. H is your horizontal translations, left or right. And I think the one thing you have to remember about this is the word opposite. And because the best way to describe it is if the value is x, for example, I'll just give you one real quick. If it's like x minus 2, that is actually right 2. If it was x plus 2, then it's actually going to be left 2. And there is a reason for that again. K is your vertical translation, up or down. So, plus K is up, minus K is down. So that's what we're going to be working on here to start off with for the first set of attributes. Okay. So what we're looking at is the square root and the cube root function. Okay. So first I'm going to talk about the parent functions. This is what the parent functions are. Okay. We have this point here called HK. Okay. That is what we're going to call the starting point for the square root function. Sometimes you'll hear the term vertex point. Sometimes you hear the term locator point. They all pretty much mean the same thing. Okay. It's a square root of x. Looks like this. You have a starting point, goes on forever in this direction. Okay. That's the primary parent function for square root. Then you have the cube root function, which kind of sort of looks like the square root, except it's got the backwards part of this here. And that's just because you can actually take cube roots of negative values, whereas you cannot take square root of negative values graphically. Now, yes, we can talk about imaginary numbers, but we're not going to go that far. The main point of this one you want to know is this point right here, which happens to be the same point. We call this also HK. But in this case, we call this a pivot point, or in some cases, a rotation point, depending on who you talk to. But again, it means the same thing. And so we're looking at A root B x minus h plus k. So this is your vertical stretch compressions and reflect about the x. Horizontal stretch compression, reflect about the y. Shift left or right. Again, this is the opposite value here. Shift up or down based on the k. And then this is cube root. It's the exact same thing, notice. So I'm gonna go through this one here. It's the exact same one I just did. So that's what we're looking at. Okay. So I'm gonna put this aside for right now, and I'm gonna show you essentially how you want to do this. Now, there are a couple ways you could do this. If you're not familiar or not used to using this, which again, if you do, I would definitely have that in front of you. You can also kind of graph it and kind of get the idea. So I'm going to show you that, kind of rehash graphing one more time. But again, I want to do negative square root. And then you have x plus 2. And then make sure you go to the outside by going out minus 4. And so that when I graph, it'll look something like this. Okay, so I'm going to get some points real fast and graph it. And the first thing that pops up is this negative 2, negative 4. And that point is actually important because that point happens to be my starting point for the new graph. Okay, negative 1, negative 5, right there. And I'm gonna just kind of draw this down like this. It's gonna go off the graph a little bit, but it's okay. Because what I want to basically determine is what are the transformations from the parent function to this function right here. Okay, and if you graph it, you can kind of tell this. And here's kind of what you want to look at. To get from this point to this point, I had to go this direction 2 units, which is shifting left 2. So that's one of the transformations. Okay, and you can tell because of that plus 2 right there. I also had to go down 4 units to get to that point. Okay, and so this one right here tells me that I'm going down 4 units. And then the other thing also you notice is that this one goes up this direction, this one goes down this direction. And so what happens is this negative right in front, which is an A value, is a reflection across X. Now, one thing I want you to understand is that not everything's going to look like a reflection across the X where it goes from here to here. Sometimes, you'll have one that's up here that goes down like this. I don't have one right now to show you. That's still considered a reflection across the X. And the reason being is because of the order of transformations in which they occur. So just know that is what this negative value actually stands for. Okay. So I'm looking at the cube root function here. And again, that's the point that I'm looking at right there. Is my pivot point or my rotation point. And again, I'm going to graph it in my calculator real fast so you can kind of see what it looks like. Okay. And again, I have 1/4 the cube root, and cube root is under the math menu. Number 4. And then now I have this 2, oops, just kidding, sorry. 2 parentheses x plus 1. So right off the bat, I know 2 things. One, this 1/4 and this 2 are not shifts anymore. This plus 1 is going to be a shift when I graph it. And there's what it looks like. And sure enough, that's almost like a straight line, but it's not a straight line. So I'm going to pull some points off real fast to kind of graph. There's -1, 0. So there's a shift here. There's that point. And then I'm going to see if I can get another one somewhere. Let me see. Is there another one somewhere? No. Let's do this 3 1/2, which is about right there. And then I'm going to assume, oops, just kidding. I'm going to assume there's a -3 1. Let's see. -5 and -1/2. About right there. It's a very, very thin graph. And that's okay. That does happen. Okay. But notice what it does. Not only did it shift this direction, shift it from here to here, left 1. That's what this plus 1 is right here. So this is a left 1 shift. Okay. But it also got flatter, and it looks like it kind of got stretched out this direction like this, and it got crunched like this. So this is what this tells me. This 1/4 is a vertical compression of 1/4. And this B value is a horizontal compression of 1/2. I know that one's a little confusing. But basically what's happening is it's kind of getting crushed this way and getting kind of stretched out this way like this. I mean, compressed this way like this. It's easier to show you when there's numbers, but in this case, that's what you're looking at. Okay. So I know these are a little weird in terms of what we're looking at. So it's really good just to kind of know and understand the way this one works. This is the one that is the most confusing because you think it's 2 and you're thinking it's a stretch. No, it's actually a horizontal compression by a factor of 1/2. And so Okay, so look at the next two. Try them yourself. I'll be back here in a sec. I'll be back in a second. Okay, so here are the next two, 4 and 5. So again, I graphed it. It looks something like this right here. Okay, notice it went from this point, to this point. That's a shift up. So that 5 is your K value, so it's a shift up. And this 1/6 right here is a horizontal stretch by 6. Okay, so it kind of got stretched out kind of this way. You can kind of see that it goes from here to here, how it got really stretched out this way. Okay. The next one had a bunch, and the graph was really, I'll show you what my calculator looks like, kind of like this. So just kind of get an idea. Looks like this, but here's what we have. So you have the first negative, that's a reflection about the x. You have this 7, which is a vertical stretch of 7, which was what causes it to look the way it looks right now with this big old stretch like this. This negative on the inside now is a reflection about the y-axis. Then you have this 4, which is a shift right of 4, and you can tell that because if you're going from this pivot point to this pivot point, you have to go 4 to the right, and then you have to actually go up 2. So the last one you should have is up 2 that way. Okay. So it's transformations. In a nutshell. Again, I would definitely get used to reading this. I'm not so much worried about the HK. The A and the B are the ones that, will usually confuse people. I get that. The B especially, okay, when it comes down to it. All right. So the next thing I'm talking about is domain range and intercepts. Okay. So you're given a graph. You have a parent function. Okay. So again, you're starting at a pivot point. From what I talked about a minute ago, is this point right here. That's what we call HK. And in this case, my starting pivot point would be 0, 0. Okay. In this case, it's a starting point. So that's what I'm looking at. My domain. So here's kind of the way domain works on this one. Your starting point on your x-axis, which is your domain, goes from this point in this direction. Okay. So your domain, therefore, starts at 0 and goes towards infinity. Okay. Your range goes in this direction. So your range is going to also go from 0 to infinity. So square root functions will use your starting point as part of your domain and range. And that's very important to know. Okay. Your x-intercept. In this case, my x-intercept happens to be at 0, 0. And my y-intercept also happens to be at 0, 0 in this case. Okay. For a cube root function, again, your starting point or your pivot point, which is this point right here, it happens to also be at 0, 0. But now your domain's a little different because you have arrows going in both directions. Forever here, forever here. So your domain is from negative infinity to positive infinity. Your range, now here's the thing I'm going to say about this. We know that this graph goes on forever, and it does keep getting higher here. It also keeps getting lower here. That being said, your range, therefore, will be also negative infinity to positive infinity. Your x-intercept in this case happens to be also 0, 0. Your y-intercept also happens to be 0, 0. Okay. So there you have it. Okay. So I'm looking at a graph that actually has been transformed like this. Okay. So if I'm looking at my starting point or my pivot point in this case, I'm looking at the point where the graph turns, which is this point right here. And that looks like it's going to be at 2, negative 4. So my pivot point would be at 2, negative 4. My domain, again, because it's a cubic root function, will be negative infinity to positive infinity. My range is going to be the same, so that's not going to change any. My x-intercept, now, I will be honest with you, without the graph, without the equation, I don't know what it's going to be. I know there is one, but right now I cannot determine it without the equation. So right now I'm going to put cannot determine with that equation. There is a way to do it, but For right now, I cannot tell. However, my y-intercept, I can tell, which is this point right here, and that looks like it's going to be at 0, negative 5.5-ish. Okay. So that does happen. If you have an x-intercept, there is going to be one somewhere, but without the actual equation to go with this, I don't know what it will be yet. And there will be a point when, you'll be shown how to do it when you have the equation. Okay. 2 more. Okay. Starting point or pivot point. In this case, it's my starting point. Okay. It looks like it's going to sit at 2, 3. Okay. My domain looks like it goes from this point, this direction. So those are going to go from 2 to infinity. My range, here's my pivot point again, which goes to 3. But the graph goes down. And since it goes down, it's going lower. And since it goes lower, that means my highest point is going to be 3. And so in this case, I need to reverse my range to where negative infinity is my lowest and 3 happens to be my highest in this case, because I'm actually going down in terms of graphing. My x-intercept looks like it's going to be 11, 0. My y-intercept, now notice because this is your starting point, the graph does not extend this direction. Since it does not extend in this direction, it does not have one. There is no y-intercept, which does happen sometimes. Okay, which does happen sometimes. Last one. Now, if you want to pause and try this one on your own first, by all means, go for it. All right, this is what it looks like. Pivot point, my starting point looks like it's at 2, 5. My domain, therefore, starts at this point and goes in this direction, so 2 to infinity. My range starts at this point. It looks like it goes up, so 5 to infinity. This one doesn't actually have an x-intercept because it doesn't cross the x-axis. This one doesn't have a y-intercept either because it does not cross the y-axis. So sometimes it's possible that you have a square root where you don't have an x or a y-intercept. Okay. On the flip side, let me go back to the one I just did a minute ago. This one right here, even though it doesn't show in the graph, the one thing about cube root is there is an x-intercept somewhere. It's just a matter of knowing where it's at because of without the equation, we don't know that. Okay. So kind of recap again, vertical stretch compression, also reflection about the x if it's negative. Horizontal stretch compression, again, reflection about the y if it's negative. Shifting left or right, again, if it's a minus, it's shifting to the right. If it's plus, it's shifting to the left. Shifting up or down, again, plus is up, minus is down. You have your 2 square and cube root functions. You have a starting point, you have a pivot point, depending on which one you're looking at. Again, that's your HK value that you're looking at. HK. Okay. Square roots may or may not have x or y intercepts. Cube roots will have x and y intercepts, although sometimes the graph is not nice and you can't tell without the equation what it is. All right. I think that's everything, folks. Yeah, looks like everything. So there you have it. Kind of some basic attributes you want to know for square root, cube root functions. And we'll see you around.